All right, so number 15, graphing problem. Now, here we have position, so x is position. Just make this super clear. The y-axis is position. It's where you are on the earth, and then t is time. So the slope, the thing to know on a position time graph, slope is equal to what? Well, it's rise over run, right? Slope is rise over run. So let's just look at this first segment right here. What is the rise for that first segment? Well, yeah, it's 10. It is 10. But what is it? What is that rise? It's the change of position, right? It's the displacement. What's the run? The time. What's displacement over time? Velocity. So we're basically they're asking for us to find instantaneous velocity at these different times. Okay, let's revert. All right, so the first time is t equals 1. Now, what is super duper nice about t equals 1? It's on a straight line, right? See this whole first segment right there? The slope of that line is constant, right? If the slope is constant, the velocity is constant, right? So whatever the velocity is at t equals 1, it's the same here, 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 everywhere on that first line. Make sense? All right, so I'm going to use this point and that point. Doesn't matter which points you use. You can use any 2 points if you're finding the slope of a straight line. So for A, we're focusing at t equals 1. The average or the instantaneous velocity is going to be delta x over delta t. So the delta x is going to be the rise. That's 10 meters. That's the change of position. And then what's the time? 2 seconds. That's going to be 5 meters per second positive. And you would have gotten the same answer if you used 2 other points. Like if you would have done like right here. Like let's say you did t equals 0 and t equals 1. So you would have gotten the same answer. Delta x over delta t. What's the rise now? There. 5. What's the run? 1. So you still get 5 meters per second. The velocity, because the slope's constant. Okay, B. At t equals 3. So look, t equals 3 is right there, and a lot of you are asking like, well, hey, at t equals 3, is that 7.5? My answer is, it don't matter. You know why it don't matter? Because the 2 points I'm going to use, so we're trying to find the velocity right here, right? Is that on a straight line? Yeah, so I'm going to use this point and that point, right? I'm going to use those 2 points. All right, so velocity is delta x over delta t. Now, guys, you got to pay attention here. Change is always final minus initial, right? That's what change is. So final is going to be this guy. So what's the position here? About 5. So 5 meters minus the initial up there, which is 10. So what's going to happen? So 5 minus 10 is negative. And then the time, the run here is 2 seconds. So for part B, the velocity comes out as negative 2.5. And why does it make sense that it's negative? Because the slope of this line right there is what? Negative. And what does that mean? If we think about our object here, so let's say it's a car, right? What was happening in the first 2 seconds? In the first 2 seconds, the object was moving which way? To the right. To the right is plus, to the left is minus. Then what happens from t equals 2 to t equals 4? It moves negative. It's moving in the negative direction. All right, that's why the velocity is negative. All right, part C. The velocity at t equals 4.5, right here. So I'm gonna revert back. clean this up. So 4.5 is right there. What's the slope of the line there? 0. So the velocity is 0. But if you want to be real thorough, you would delta x over delta t. So let's use that point and that point, right? So what's the time from 4 seconds to 5 seconds? 1. And then this is going to be, final minus initial. That's going to be 5 meter minus 5 meter, which is 0. There is no slope. So there's no velocity. Yo.
On a test, you just want us to write 0, or do you want to show, that?
You could just write 0. And then maybe just say slope is 0. Just so the grader knows. Okay, t equals 7.5. Right there. Okay, this is a straight line. I'm going to use this point and that point to find the slope. So delta x over delta t. So that's going to be final minus initial over, so the time is going to be from 7 seconds to 8 seconds is 1 second. All right, what's the final position? 0. And then, hold on a second. And then, hold on here. This is important. So look, 0 minus -5. What happens to those negatives? They cancel and you get +5, which makes sense because the slope is positive.